Hey guys, this is Mr. Kirilla. We're going to talk about compound inequalities. A compound inequality is when we join two inequalities with the word and or with the word or. So if we have an inequality like 3 is less or equal to x is less than 5, this basically means two things. X is greater or equal to 3 and x is less than 5. Using the word and, these are joined. So both of these conditions have to happen. So we're going to solve a couple of these examples. Problem number 1, we have the simple compound inequality. And as you notice here, we can solve this all together. And we're going to have more than two sides now. We're going to have the left side of the inequality. We're going to have the center. And then we're also going to have the right side of the inequality. So when we do one operation on one of these sides, we're going to carry on this operation two more times on the other sides. So the variable in this case is located right here in the center. X is my variable. Along with the variable, I have multiplication and subtraction. We're going to tackle the weakest link, subtract 4. And inverse operation to subtraction, it's addition. So we're going to add 4 to all three sides. By addition, we're going to have a new inequality. We're going to have 2 plus 4 is 6 is less than 3x. 4 minus 4 is 0. And 14 plus 4 would be 18. So now we have a new inequality. 6 is less than 3x is less or equal to 18. Our variable is still in the center. We have multiplication, multiply by 3, inverse operation, divide by 3. We're going to divide by 3 on each side. Well, 3 is a positive number, so we're not going to change the sign of the inequalities. So we're going to have in the end 2 is less than x is less or equal to 6. So the answer for my compound inequality actually can be written as a number line, it can be drawn as a number line, or it can be written as an interval notation. Let's show them both. We're going to start from 0. We're going to count by 2. 0, 2, 4, 6, and 8. We will circle 2. We will circle 6. 2 is unshaded. 6 will be shaded in. And we would have everything in between 2 and 6. If I want to use an interval notation to represent the same answer, we're going to use round parentheses 2 and 6 bracket. And that's because we have the equal sign under 6. So this is the first example. Moving on to the second example, we see that the signs for the inequalities are oriented backwards. -5 is greater than 2x plus 7, which is also greater than -13, but in the end it will be the same strategy. Our variable is in the center. Along with the variable, we have multiplication and addition. Weakest link is addition, so we have add 7, inverse operation, subtract 7. We're going to subtract 7 on all three sides. Our new inequality is going to be -12 is greater or equal to 2x, and then this is also greater or equal to -20. The last operation we have to undo is multiplication, multiply by 2, inverse operation, divide by 2. We divide by 2 on all three sides, and we're going to have our new values. -6 is greater or equal to x is greater or equal to -10. Or if we read this backwards, we would have -10 is less or equal to x is less or equal to -6. And that should be a little bit better for graphing. If I want to graph this on a number line, we can start with the number line and count maybe by 2. We're going to start with -12, -10, -8, -6, -4. We're going to circle -10 and -6. We will shade it in because we have the equal sign for our inequality, and then we're going to connect these two. As an interval notation, -10, -6, and both of them will have brackets. So as you notice here, for both of our examples, we had compound inequalities with the word and. We can solve it all together, and at the end we have two choices: either graph the solution or write it using interval notation. Thank you and have a wonderful day.